Alright, this podcast is LG2. I can graph a linear equation by making an input and output table and also using intercepts. Okay, so we are going to start with graphing by using intercepts. So to graph by using intercepts, the first thing that we need to do is find both of the x and y intercepts. Then we need to plot the intercepts on a graph and then connect the intercepts with a line. To check, we can always find a third set of coordinate points using a table. The third point should always be on the line. Alright, so first, finding the x-intercept. For the equation 2x plus y equals 6, we know that y must equal 0. Now, why do we know that? Because when we graph x and y intercepts, so if I go back and I create a graph, and I make a line on this graph, I can identify the x and y intercepts. Okay, so looking at this first point here, I can show that this is my y-intercept. So my y-intercept is when x is 0, and on this particular graph, y is 7. Now my x-intercept, my x is -8, and my y is 0. Okay, so when it crosses the x-axis, that is the x-intercept. When it crosses the y-axis, that is the y-intercept. So why must x equal 0 is because of that. So looking on that last graph, the y-intercept, the x equals 0. So if we're trying to find the x-intercept of a line using an equation, we need to put 0 in for y. So in this particular case, I put 0 in for y in the equation, so 2x plus y equals 6, and I substituted 0 in. So go ahead and solve. 2x equals 6, divide by 2, x equals 3. So 3, 0 is the x-intercept. 3, 0 is the x-intercept. Okay, so again, I was finding the x-intercept. So if you notice, for the x-intercept, y is 0. For the y-intercept, x is 0. So this particular one, we were looking for the x-intercept. Okay, so now if I'm trying to find the y-intercept. So for the y-intercept, we know that x must equal 0. Because, going back here, again, the y-intercept, x, is 0. So why must it be 0? Because that's where it crosses. So we're going to substitute 0 in for x and simplify. So 2 times 0 plus y equals 6. 2 times 0 is 0, plus y equals 6. So therefore y equals 6. So since we plugged in 0 for our x, our ordered pair is 0, 6. Because remember, you always list 0, x, then y. So we plugged in x for our equation. So to summarize, to find the x-intercept, we substitute 0 in for y, and to find the y-intercept, 0 in for x. So this right here is the key to what we have to remember. So make sure you have this wrote down. Okay, so let's try some more examples. All right, so we are given the equation x equals 4y minus 5. It's telling us to graph the equation. So we're going to first find the intercepts to be able to graph this. So to find the x-intercept, like we just learned, we have to plug 0 in for y. So I'm going to plug 0 in. So my equation x equals 4y minus 5, plug in 0 for y. So it's 4 times 0 minus 5. 4 times 0 is just 0. So 0 minus 5 is negative 5. So if you notice, we solved for x equals negative 5. Okay, so if x equals negative 5, we plugged 0 in for y. So we know, since we plugged 0 in for y, y has to be 0. Okay, over here, now we're going to solve for the y-intercept using the same equation because we're trying to find the x and y-intercept of that linear graph. So we're going to plug 0 in for x. So equation 4y minus 5. This time I'm putting 0 in for x, so 0 equals 4y minus 5. We're going to add 5 to both sides to get the y by itself. So I have 5 equals 4y, divide by 4, so y equals 5/4. So again, we substituted 0 in for x, so in our ordered pair, it is 0 5/4. Okay, so then we go ahead and plot our points. So the first point that we need to plot, so going back to our x-intercept, we found that our x-intercept is negative 5, 0. So going to my graph, negative 5, 0 is right there. We solved for our y-intercept to be 0 5/4. Okay, so 5/4, 4/4 is 1, so 5/4 is just above 1. So 0 5/4 is right here. So we plotted our points, and then you connect your intercepts with a line. All right, so go ahead and try this one. You can pause it at this time and try it on your own. And then I'm going to go ahead and go to the next problem, and I'm going to do this one for you. Okay, in this one we have, it's already in standard form. Okay, so go ahead, we're going to do x-intercept. X-intercept of this one, again, we plug 0 in for y. We're going to show that. Remember, whenever we substitute numbers in for variables, we always use parentheses. So 6x minus 3 times 0 equals negative 18. So again, since I put 0 in for y, down here my ordered pair 0 is going to be y. So we're going to go ahead and solve. 3 times 0 is 0, so I just am left with 6x equals negative 18. Divide by 6 on both sides, so x equals negative 3. So my ordered pair is negative 3, 0. Okay, so for the y-intercept, we plug x in for 0. So again, we know that our point is going to be 0 something, so we plug that 0 in. 6 times 0 minus 3y equals negative 18. So 0 minus 3y equals negative 18. So negative 3y equals negative 18 divided by negative 3. So negative 18 divided by negative 3 is 6. So we have negative 3, 0. We're going to go plot our points. Negative 3, 0 is here. And then our other point was 0, 6. So 0 up to 6. And we connect with a point. Okay. All right, so now just a little bit different. If you notice, our equation is x equals 3. So if we're trying to find x and y intercepts here, to find the x-intercept, you have to plug 0 in for y. So we have a problem. There is no y. So there's no y because x equals 3 is vertical. Okay, x equals 3 is a vertical line because x always equals 3. So looking at this graph, on this line, you will see that at every point, x is 3. So it creates a vertical line. Therefore, it never crosses the y-axis. Okay, so we never have a y-intercept here. Okay, so since we never have a y-intercept, oopsies, we can't solve for it. Okay, so a vertical line doesn't cross the y-axis. It does not have a y-intercept. Okay, now, just the opposite. Now I have y equals negative 2. So again, for x-intercept, we put 0 in for y. Well, we can't because y cannot equal 0 because y equals negative 2. So y equals -2 is a horizontal line, so it never crosses the x-axis. There is no y-intercept. So if if y equals -2, it's going to look like this, because at every point on here, y is -2. Every single point, y equals -2. So therefore, it creates a horizontal line. So when it goes to finding the y-intercept, your y-intercept is going to be 0, -2, because that's where it crosses. Right there. All right, now the second part of this learning target is to create a table of graphs, or excuse me, a table to graph. So to find ordered pairs that are solutions to the linear equation y equals 3x plus 1, list these in table 1. So what we're going to be doing here, we're actually going to be substituting these numbers that I have in the table in for x to solve for y, and then we're going to plot the points. Okay, so I have y equals 3 times, I'm going to substitute -2 in, plus 1. It's a little bit smaller here. Okay, and I can go ahead and solve that. 3 times -2 is -6. -6 plus 1 is -5. So my ordered pair here, x was -2, and I solved for -5. All right, here we're going to do the same thing. However, we're plugging in -1. So y equals 3 times -1 plus 1 equals 3 times -1 is -3, plus 1 is -2. Okay, so our ordered pair here is -1, -2. Next, now we're going to plug in 0. So we plug in 0. Y equals 3 times 0 plus 1. 3 times 0 is 0. Plus 1 is 1. So again, we have 0 because we plugged that in for x, and we solved for 1. Keep going here. Y equals 3. Now I'm plugging in 1 plus 1. 3 times 1 is 3, plus 1 is 4. So our ordered pair here is 1, 4. And the last one. It's always nice to have 5 points. Then we know exactly which direction this graph is going. So 3 times 2 plus 1 equals 3 times 2 is 6, plus 1 is 7. So our ordered pair here is 2, 7. Okay, so now that we know the ordered pairs, we can go ahead and plot our points. So we have -2, -5. We have -1, -2, 0, 0, 1, 1, 4, and 2, 7. And we connect with a line. Okay. All right, so next I want you guys to go ahead and try this last one on your own. So this concludes the podcast, LG2, that learning target about solving for x and y intercepts, and also graphing using a table.